Hello everyone, this is Kushi Verma from M.Tech IT 2K21 batch of IIPS DAVV. In the last videos, we discussed all the MST question papers of NAD M.Tech 4th semester. In this video, we'll discuss the final question paper, that is the EndSem question paper of NAD M.Tech 4th semester. Question 1 goes like, find the roots of the polynomial x square minus x minus 1 through fixed point iteration method. Also make a table for the various possible equations and show whether they are convergent or divergent in nature. First of all, we'll make an assumption, that is, let us assume we have an equation f of x which is equal to x square minus x minus 1, and we have f of 1 equals to negative and f of 2 equals to positive, so that we can find out a root for the equation. On solving the equation f of x, we get that the root is between point x equals to 1 and x equals to 2. Considering both the points, we can take x0 equals to 1.5 as median value. In the next slide, you can see that we have a table which is having the values of g of x, g dash of x, mod g dash of 1 and mod g dash of 2. This table will help us find out the equations g of x that can be made through f of x. For selecting the correct g of x, or for finding out the correct values of g of x, we have to follow certain conditions. The first condition that we have to follow is that mod g dash of x should always be less than 1. The second condition is, if multiple value of g of x are less than 1, then choose the least one. The second condition says that if we get multiple values which are less than 1 for the equation g of x, we'll have to choose only one value, which should be the least one. Okay. On following the above two conditions, we'll get the table for the convergence. Here in this table, you can see we have two values for g of x. One is under root of x plus 1 and x square minus 1. For g of x equals to under root of x plus 1, we get two set of values. One for mod g dash of 1 and the other one for mod of g dash of 2. Here we get the first set of values, that is less than 1 and less than 1, for which g of x has convergent nature. The second set of values for g of x equals to under root of x plus 1, we get greater than 1 for mod g dash of 1 and greater than or equal to 1 for mod g dash of 2, which is divergent in nature. The third set of values for the equation g of x equals to under root of x plus 1 is greater than or equals to 1 for mod g dash of 1 and less than 1 for mod g dash of 2, which is also divergent in nature. The second equation, that is g of x equals to x square minus 1, we get g dash of x as 2x and less than 1 for mod of g dash of 1 and less than equal to 1 for mod g dash of 2. This equation for g of x is divergent in nature. In the next slide, we put g of x equals to under root of x plus 1 for fixed point iteration method. यहाँ पर हम x0 1.5 ले रहे हैं क्योंकि हमने फर्स्ट स्लाइड में f of x equals to x square minus x minus 1 इक्वेशन के लिए हमने दो वैल्यूज फाइंड आउट करी थी रूट की वजह से, जो कि x equals to 1 और x equals to 2 थी. अब इसकी मीडियन वैल्यू निकाल करके हमने x0 को 1.5 अज्यूम किया था. यह हमारी फर्स्ट अजम्पशन थी फर्स्ट स्लाइड में. अब हम x1 को फाइंड आउट करने के लिए g of x वाली जो इक्वेशन है उसमें x को x0 के इक्वल रखेंगे. तो x1 विल बी अंडर रूट ऑफ x0 plus 1, that is 1.5 plus 1, which will be equal to 1.5811. For x2, for finding out x2, we'll put x1 instead of x. For finding out x1, we put x0 in the place of x. तो हम लोग x2 फाइंड आउट करने के लिए x की जगह x1 रखेंगे, एक पीछे वाली स्टेप. तो for x2 we'll get under root of 1.5811, which is the value of x1 plus 1, which will be equal to 1.6065. Similarly, we'll get the values for x3, x4, x5, x6 and x7. As you can see, we got the values x3 as 1.6144, For x4 we get 1.6169, for x5 we get 1.6176, for x6 1.6179, and for x7 we get 1.618001. As the error between x7 and x6 is 0.000101, we'll neglect this part, and hence the root of x square minus x minus 1 is 1.618001. As we get क्यों हमने निग्लेक्ट कर दिया है, क्योंकि इन दोनों के बीच का डिफरेंस काफ़ी माइन्यूट था, जिसकी वजह से हमने उस डिफरेंस को निग्लेक्ट किया है। और उस डिफरेंस को निग्लेक्ट करने के बाद में हम इस कंक्लूजन पे पहुंचते हैं कि x6 और x7 की वैल्यूज जो निकल रही है वो काफ़ी हद तक सेम है, neglecting the difference wala part. So we'll stop the iteration over here, and for root of x square minus x minus 1, we'll consider the root as 1.618001. ठीक है, the first question ends over here. On coming to second question, find the solution of the system of equation using iterative method. हमें iterative method को use करके system of equation को solve करना है। हमारे पास तीन equations है, 20a plus b minus 2c equals to 17, 3a plus 20b minus c equals to minus 18, 2a minus 3b plus 20c equals to 17. सिस्टम ऑफ इक्वेशन को सॉल्व करने के लिए चार तरीके की मेथड्स होती है। एक होती है गॉस एलिमिनेशन मेथड, एक होती है गॉस जॉर्डन मेथड, और फिर बाकी दो आती है इटरेटिव मेथड। इटरेटिव मेथड जो दो है वो हमारे पास एक जैकोबी और एक साइडल, गॉस साइडल मेथड। हम यहाँ पर जैकोबी मेथड का यूज करेंगे फॉर फाइंडिंग आउट द वैल्यूज ऑफ ए बी एंड सी। जब हम सॉल्व करने जाएंगे तो हम इन इक्वेशंस को इस तरीके से पुट करेंगे ताकि हम a, b और c की वैल्यूज को निकाल सकें। We find the value of a, b, c in the respective equation by taking variables from one side. A equals to 17 minus b plus 2c whole upon 20. B equals to minus 18 minus 3a plus c whole upon 20. C equals to 17 minus 2a plus 3b whole upon 20. Now let us assume, let us take a0, b0 and c0 as 0. So on putting the values a0 equals to b0 equals to c0 equals to 0, we'll get a equals to 17 minus 0 plus 0 whole upon 20, b equals to minus 18 minus 0 plus 0 whole upon 20, c equals to 17 minus 0 plus 0 whole upon 20. On which on solving, जब हम इन्हें सॉल्व कर देंगे तो a1 की वैल्यू 0.85 आएगी, b1 equals to minus 0.9 and c1 equals to 0.85. On second iteration, we'll put the values a1, b1, c1 in the place of a, b and c. On solving these equations, we'll get this, and we will get a second set of values for a, b and c. a2 equals to 0.98, b2 equals to minus 0.985, c2 equals to 0.63. On the third iteration, similarly, we'll iterate the same step again and again, and we'll get two more set of values. A3 as 0.96225, B2 as minus 1.0155, C3 equals to 0.6042. On the on the fourth iteration, we'll get the values A4 equals to 0.961195, B4 equals to minus 1.0141, C4 equals to 0.6014. These iterations will be followed again and again until we get repeated approximate values. The next question is, list out 4 advantages of Gauss elimination and 3 advantages of iterative methods over the eliminate method. So, the iterative method is superior to elimination method due to these 3 advantages. First advantage is computational effort is approximately 2n to the power 2. That is 2n square arithmetic operations per iteration. And if convergence is achieved in less than n iterations, it is significantly superior compared to the elimination method. The second advantage over Gauss elimination method is another important. The iterative method is small rounding error, the rounding error being the one committed in the last iteration. Thus, for ill-conditioned system, an iterative method is a good choice. The third advantage is, in Gauss-Seidel method, we set xi equal to the newly calculated value of the iterate stored in temp. The disadvantages of Gauss elimination are as follows. The first disadvantage is the computational effort is approximately 2n to the power 3 whole upon 3 arithmetic operation in each elimination step. The second disadvantage is the amount of bookkeeping necessary is considerable. The third disadvantage is the rounding error may become quite large, particularly for ill-conditioned equations. The fourth and the last disadvantage of cross elimination method is that any special structure in the matrix of coefficient is difficult to preserve during elimination. The next question is write the algorithm for the Lagrange inverse interpolation. As you can see, here are the steps. These are the steps for the algorithm of Lagrange inverse interpolation. The first step is read number of inputs n. The second step is read the value of x. The third step is for I equals to 0 to I equals to n minus 1, read xi and yi. The fourth step is set sum equals to 0, and the fifth step is for I equals to 0 to I equals to n minus 1, set the product equals to 1. For j equals to 0 to j equals to n minus 1, if I is not equal to j, product equals to product into y minus yi whole upon yi minus yj. The sum equals to sum plus xi star of product, and the last step is print sum. The next question is evaluate the function. The next question is evaluate the given function using the 3-point Gauss quadrature formula for the given abscissa and weight. We get the following given details: T1 equals to 0.77459667, T2 equals to 0, T3 equals to minus of T1, W1 equals to minus 0.555556, W2 equals to 0.8889, W3 equals to W1. Let A equals to 0 and B equals to 1. X equals to b minus a whole upon 2t plus b plus a whole upon 2. On putting the values of a and b in the above equation, we get x equals to 1 plus t whole upon 2, that is dx equals to dt by 2. On substituting the values of x and dx in the f of x, we get f of t equals to integrate limit minus 1 to 1 for 2 whole upon 4 plus 1 plus t2 dt. On putting the substituting the value of x and dx in the f of x, we get f of t equals to minus 1 to 1 2 whole upon 4 plus 1 plus t2 dt. Ft equals to 0.555556 f of minus 0.7745 plus f of 0.7745 plus 0.888889 f of 0 minus 1 to 1 of 2 whole upon 4 plus 1 plus t2 dt equals to 0.555556 of 0.493723 plus 0.27976 plus 0.888889 of 0.4. On solving which, we get minus 1 to 1 for 2 whole upon 4 plus 1 plus t2 dt equals to 0.78527. The next question is write an algorithm for the Wedel's rule for the 6 points. The first step will be read start. The second step is read end. In the third step, h is equal to n minus start whole upon 6. In the fourth step, for I equals to 0 to I equals to 6, read by I. And in the fifth step, s equals to 0.3h of y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. And the last step is print s. Write the algorithm for the Runge-Kutta fourth order expression. The first step is def f of x comma y, that is define f of x comma y and return the expression. In the second step, we'll have to read the starting and ending along with the splits. In the third step, h is equal to ending minus starting whole upon splits. After that, while starting is less than or equal to ending, we'll have to put k1 equals to h star f of x comma y, k2 equals to h star f of x plus h by 2 comma y plus k1 by 2. For k3, h star f of x plus h by 2 comma y plus k2 by 2, K4 equals to h star f of x plus h, comma y plus k3. X equals to x plus h, starting equals to starting plus h, y equals to k1 plus 2k2 plus 2k3 plus k4 whole upon 6 plus y0, and then print x comma y. The last question is apply predictor corrector method to solve dy by dx equals to minus xy comma y equals to 0 equals to 1 in steps of 0.1 up to y of 0.2. For yn plus 2, we have yn plus 2h f of xn plus 1 comma yn plus 1. For yn plus 1, we have yn plus h by 2 of f of xn comma yn plus f of xn plus 1 comma yn plus 1. By Young's method, we have k1 equals to f of xi comma yi, k2 equals to f of xi plus h by 2 comma yi plus k1 h by 2, and k equals to k1 plus k2 whole upon with 2. For yi plus 1, we have yi plus kh, and hence we get y of 0.1 as 0.9975. We get y of 0.2 equals to y0 plus 2h f of x 0.1 comma y of 0.1, which is predicted, and y 0.2 equals to 1 plus 2 into 0.1 into minus 0.1 into 0.9975. And on solving the above equation, we get y of 0.2 as 0.98005. Y of 0.2 equals to y of 0.1 plus h by 2 of f of x of 0.1 comma y of 0.1 plus f of x of 0.2 plus y of 0.2, which is again predicted. Y of 0.2 is equal to 0.9975 plus 0.1 by 2 of minus 0.1 into 0.9975 minus 0.2 into 0.98005. On solving which, we get y of 0.2 as 0.982712, which is corrected. We can apply a corrector formula again for more accurate value by putting this corrected value as predicted value in the corrector formula as done earlier. Thank you.